So now we're actually going to solve them. So we're going to have x or whatever you want for the unknown quantity. I usually just stick with x so it's consistent. And we're going to set up a proportion. And because it has the equal sign in it, we can then solve. And we'll solve for whatever our unknown is. So let's set one up and then we'll talk about solving it. So what is 12%? So we're going to have 12 over 100 of 80. So 80 is the of number. It's is over of. So we're going to put 80 down here. So what is, there is our unknown. The is unknown. So that is where we put our x. So x over 80 equals 12 over 100. Now from here, there are a number of ways to solve that you guys might be comfortable with. Whenever you have one fraction equals one fraction, you can cross multiply. That does work to solve it. But if it is ever more than a single fraction equals a single fraction, you need to do something different. It only works when you have one fraction, the equal sign, one fraction. Just one fraction on each side. Anything else, and you need to think differently. Now, the other thing I want you to note, though, is so that x is on top, and it's just being divided by 80. So if I look at this, put my equation cap on instead of my percent cap, x divided by 80 equals 12 hundredths. Well, I just want x, so I got to get rid of divide by 80, and I can do that. The opposite would be multiply by 80. But since it's an equation, to preserve my balance, I also multiply the other side by 80. And now we just need to crunch that, which is let's see, calculator. 12 divided by 100 times 80. 9.6. So we can say 9.6 is 12% of 80. And if we look at 80, 10% of 80, you move the decimal once, would be 8. This is a little bit bigger than 8. 12 is a little bit bigger than 10 for percent. So that is a reasonable answer. All right. Whoa, wrong button. So now 7.5%, woohoo, fill it out while you got it. And note, like we just copy the number, whatever it is, and put it above 100. That putting it over 100 kind of takes into account that it was a percent number. So we don't have to worry about doing the conversion because the over 100 would actually convert it to a decimal, like if you were wondering that. And then 7.5% of 784 is what? So 784 is the of, and then is our unknown again. And the same logic we used over there applies. So I could cross multiply. In fact, let me do that just so you guys can see kind of the comparison. So I would end up with, and I'm going to write it to the side just because I write huge, 100x equals 784 times 7.5. I'm not even going to bother calculating that because it's just going to crunch in the calculator. I don't really care what that is because it's not just x yet. Now, when I have the 100 times x, I'm going to divide by 100 on both sides. And now this is what I'm going to crunch to solve the equation. Now, if you note, if I did what I did before, let me do this, and just multiplied by what x was being divided by, if I multiplied by the 784, I'd have 784 times that 7.5 over 100 fraction. So we get the same result different ways, and we still got to crunch the same thing. So 784 times 7.5 divided by 100 is 58.8. So 58.8 is 7.5% of 784. 10% of 784 would be 78.4. This is less than that, so this seems reasonable. But what if that is not our unknown? So now it can start looking a little more interesting. So now 15% of what number is 45? So now we have the is number. We know that's 45. And we see our percent number, 15 over the 100. So our unknown is the number on the bottom here. Now you could use the butterfly method. I've heard that before, where the 2 across you multiply and then you divide by the third. That works. That is exactly how the numbers would interact to tell you what goes in the unknown spot. But when x is on the bottom as an equation, it looks weird. So this is very much where cross multiplying works. Technically what we're doing is we're multiplying by the common denominator 100 times x. But on the left side, the x's will cancel and you'll just have 100 times 45. And then on the right, multiplying by 100x, the 100s cancel and you're left with 15x. So this is why cross multiplying works. You're doing a behind the scenes weird multiply to both sides. But if it was anything more than the one fraction equals fraction, what you multiply by would get applied to all of the fractions, and then the calculation gets a little bit more. We can still do it, it's a little weirder. So now we just got to figure out, well, 15 goes into 45 3 times, so 300. Which is totally reasonable. I wanted it a little smaller, and let me rewrite that. And 15%, well, 10% of 300 would be 30. And then half of 30 would be 15. 30 plus 15 is 45. So 45 is totally 15% of 300. It's good. All right, same song, second verse. 5 1/2%. Please don't write the mixed numeral. Write the decimal or convert it, but write the decimal. Like we know 5 1/2 is 5.5. I don't know why they wrote 5 1/2 like that. I stole these notes from someone else. And then our of is again our unknown. Our is the 22. I'm going to zoom in. So we have 22 over what equals 5.5 over 100. So 5.5x equals 2200. This one, I'm going to use the calculator. Like the other one just kind of jumped out at me as, oh, look, I totally worked this way. And I was like, you do totally work that way. Good job. This one, I don't want to. 2200 divided by 5.5. 400. We got two nice answers. Cool. I just say nice because they're hundreds numbers, but you know, they're integers. That's what I think of as nice. And you know, 10% of 400 is 40. Half of 40 is 20, and 22 is a little bit bigger than 20. So a little bit bigger than 5%, 5.5%. That sounds reasonable. Now we're going to solve, what if we don't know the percent? What if the percent is the thing we want to know? This is where paying attention to the is and the of is important. So 81 is what percent of 250? So let's go ahead with the x over 100. Then 81 is, so 81 is on top of 250, so 250 is on the bottom. And to get x by itself, I can multiply both sides by 100. So I end up with 81 times 100 divided by 250. When the x is on top, this is what I'll do a lot of the times because we end up at the calculation that much faster. But all the ways I've shown you work. So it is really get comfortable with one of the ways so you can do it all the time. You don't have to learn all the different ways. Just pick the one that seems the most useful right now. And we got, if I did 100 times 81 divided by 250, we got 32.4. So that is what x is, but we know x is also a percent. So the final answer we would say is 32.4%. That would be our units, as it were. Of course, for me, you're going to be taking online tests, so the units will actually already be filled in, or it'll be a drop-down box and you have to pick what it is. But either way, the program will force you to do it. It's not something you just have to remember to do. It's one of the bonuses of online testing. Okay. All right, now what percent, again, there's our unknown, x over 100, of 53 is 159. Of 53, 53 goes on the bottom, is 159. 159 goes on top. So note, paying very careful attention to the words and where the numbers are associated, and we filled them in that way, and we happened to get the big number on top and the smaller number on the bottom. So this tells me my x number will be bigger than 100. If I don't get an x number bigger than 100, I made a mistake. But same song, second verse, multiply by 100. And some of you may already note, like, well, 50 goes into 150 3 times, 3 goes into 9 3 times. Yeah, it's totally going to be 3 times 100. Which is 300. But if you didn't recognize that, which is totally fine, I'm just a geek who likes to think through that. Crunching on the calculator is fine. You do not need to do these in your heads. Using a store-bought calculator is totally fine. Now remember though, this was a percent, so our actual answer here is 300%. So 159 is 300% of 53. 300% is just the mathematical way of saying triple. 200% would be double. All right, pause it and then we'll come back to more equations.